Yeah, good evening, everyone. So this is algebra session, and in last session we did some identities. So this time we will have some simple problems based on identities, and not too difficult. Yeah. So here is the first one. Find n if 8 raised to 73 plus 2 the whole square minus 8 raised to 73 minus 2 the whole square is equal to 8 raised to n. Yeah, I hope problem is simple and straightforward. So all of you can solve. You can put answer of n in chat box only to me, and later on we'll have discussions. Fine. Yes, Anish, Achyutan, good. Yeah. Yes, Karthik. I want more answers, and then we'll start the discussion. Karthik, Pawan, I guess answer is wrong. And Diksha, Yanesh is correct. Vivan, correct. Anju, correct. Okay, so we can solve it in two different ways. Either I can use formula for a square minus b square, or I can separately simplify or open this bracket. I can open this bracket and simplify. Let's see. So 8 raised to 73 plus 2 the whole square is 8 raised to 73 square plus 2 times of 2 into 8 raised to 73 plus 2 square. Yeah. So that is expansion of 8 raised to 73 plus 2. We can similarly expand 8 raised to 73 minus 2 square. So that is 8 raised to 73 square minus 2 times 2 into 8 raised to 73 and again plus 4. Right? So if I subtract this minus this, what I'll get is 8 raised to 73 plus 2 square minus 8 raised to 73 minus 2 square is equal to, so see that first and the last term gets cancelled. So this gets cancelled. Similarly, this gets cancelled, right? So I'll get 2 minus minus 2, so that is plus 4. So 4 times 2 into 8 raised to 73. So that is 8 times 8 raised to 73. So by laws of indices, this is 8 raised to 74. Fine. So n is 74. Okay, so let's do it by a square minus b square formula. And of course, later on, whichever is simple, you can choose that one. Just a minute, let me check the chat box. Yes, Karthik. Can I go to next page? So another way we can do is use formula for a square minus b square. That is a plus b into a minus b, right? So 8 raised to 73 plus 2 square minus 8 raised to 73 minus 2 square is equal to 8 raised to 73 plus 2 plus 8 raised to 73 minus 2 into 8 raised to 73 plus 2 minus 8 raised to 73 minus 2, so that is plus 2. I think this is little tedious than earlier. So this is 2 times 8 raised to 73 into 8 raised to 73. Sorry, that cancels into 4. Yeah, this is also simple. Essentially, we are getting same thing. 8 times 8 raised to 73. That is 8 raised to 74. So implies n is 74, right? We can do it anyways, which are convenient to you. Shall we go ahead?
Yes, sir.
Here is second one. You have to compute, simplify 2 plus 1 to 2 square plus 1 to 2 raised to 4 plus 1 to 2 raised to 8 plus 1, 2 raised to 16 plus 1. Yeah, once you get it, you can put in chat box. Yes, yeah, good. Yes, Anish, very good. Yeah, Kian, correct. Yeah. Yes, Diksha, correct. Yes, Pawan, very good. Yes, madam. Yeah. Okay. So Anish had a nice trick. Multiply this by 2 minus 1, which is as good as 1. So this is same as this. And basically see that powers are all powers of 2. Right? So this gives me first step 2 square minus 1 into 2 square plus 1. Rest is same. Then again this into this gives me 2 raised to 4 minus 1. Right? Into 2 raised to 4 plus 1, 2 raised to 8 plus 1, 2 raised to 16 plus 1. Then again this into this gives me 2 raised to 8 minus 1. So 2 raised to 8 plus 1, 2 raised to 16 plus 1. Right? So do you see I'll get repeatedly such pairs of a raised to b minus a minus b into a plus b type of numbers, and ultimately we'll get 2 raised to 32 minus 1. All of you agree?
Yes, sir.
Yeah. Anybody has done with some any other way? Any trick? Those who have got answers. Yeah, if you want, you can simplify that 2 raised to 32 also. But let me keep it in this form itself. Shall we go ahead? Third one. This is KVJMO Junior Maths Olympiad 2001. Given x plus y is 1, where x, y are real numbers, and x cube plus y cube is 4, then what is x square plus y square? So as usual, you can put in chat box only to me, and after some time we'll start the discussion. Yeah, Anju, Anish, correct. Yeah, Achutan, correct. Yes. Okay, so x plus y is 1, and which implies x plus y cube is again 1. Right? So that gives us x cube plus y cube plus 3xy times x plus y, right? Is the formula correct? Is equal to 1 cube, which is 1. Now this part is given to be 4. So 4 plus 3xy, x plus y is 1. So 4 plus 3xy is 1. So which means xy is minus 1. Right? Now what do we want? X square plus y square. Okay, so one way is I can expand x plus y square and I'll get 2xy term there. But I know now value of xy, which is minus 1. Go to the next page. Yeah. So once again, x plus y square is 1. But x plus y square is x square plus y square plus 2xy. And I know what is 2xy. So x square plus y square minus 2 is 1. So x square plus y square is 3.
Sir, I did it slightly differently, but I
Yeah, you can quickly see
yes, sir.
what you have done.
Sir, x cube plus y cube equals x plus y into x squared minus xy plus y squared
Just a minute. X cube plus y cube.
is equal to x plus y into x squared minus xy plus y squared.
Yeah. Yes.
Sir, I can write the second part as x squared x plus y the whole squared minus 3xy.
Which one?
X plus y into
Uh,
x plus y the whole squared minus 3xy.
just a minute. So you want to say x cube plus y cube is also same as
X plus y into x.
right?
No, sir. No, sir. X plus y into x plus y the whole squared minus 3xy.
Oh, acha, ha. Okay, okay. Yes, sir. Yes, so this is x plus y into x plus y is 1. Shall I replace this by 1?
Yes, sir.
So
Sir,
it's
you
x
can replace
square.
x cube plus y cube as 3 also.
This
I mean,
is
sorry, 4.
1. Yeah. Sorry, this is 4, right?
4,
Is
sir.
equal to
Yes.
x square plus y
Sir,
square.
x plus y the whole squared minus 3xy.
Yeah, plus 2xy minus 3xy, right? Yeah. So that is x plus
Sir,
1.
when you write it, yes, sir.
So
Sir,
again, x
so
plus y is 1.
also
And
give
so this implies minus 3xy is 3.
equal to 4, sir. Yes, sir. Sorry, sir.
So xy is minus 1. Okay.
Yes, sir.
Yeah, so again you get value of xy.
Yes, sir. After that, I did it like you only, sir.
Yeah, yes. Anybody has any other variation?
Sir, I did it by x equals 1 minus y.
Just a minute. I'll go to next page. Just a So x plus y is 1 and therefore y is 1 minus x. So we bring it into one variable. That's a nice way. Yeah. So what's next then? Who's saying this method? X cube plus y cube is 4 and can replace y by 1 minus x, right? So that is x cube plus, this is 1 minus x cube minus 3x plus 3x squared, right? So x cube minus x cube cancels and therefore minus 3x times x minus 1 is equal to 3. X into x minus 1 equal to minus 1. Yeah. And then x square plus y square is x square plus 1 minus x square. So that is x square plus 1 plus x square minus 2x. That is 2x square minus 2x plus 1. Now this 2 times x square minus x is basically 2 times minus of minus 1. So this is plus 2 plus 1, right? So that is 3. Okay, shall we go ahead?
Yes, sir.
JMO question. This is Kendriya Vidyalaya JMO. Center JMO. Given x is greater than 0, such that x raised to 4 plus 1 by x raised to 4 is 47. Then x cube plus 1 by x cube is equal. Yeah, so you work out and put answers in chat box. Later on we'll have discussion. Yes, Achyutan correct, Diksha correct, Anish correct, Karthik correct, Pawan correct, Shreya correct, Ian correct, Vivan correct. Oh no, Vivan, what is that? No, sorry, Vivan, it's not correct. Yes, so that's all. So x raised to 4 plus 1 by x raised to 4 can be in terms of, so it's like x square square plus 1 by x square square, that is 47. Okay. Now, if I want to take x square plus 1 by x square, see that middle term turns out to be free of x, right? So this is x raised to 4 plus 1 by x raised to 4 plus middle term turns out to be 2 times x square into 1 by x square. They cancel with each other and we get 2, right? So that is equal to 47 plus 2, 49. These are real numbers. So x square plus 1 by x square is 7, right? Now what shall we do? We have got x square plus 1 by x square. Shall we find x plus 1 by x on same lines? Because essentially for x cube plus 1 by x cube, what we need is, or what's the formula is, x plus 1 by x into x square minus x into 1 by x, that is 1, plus 1 by x square, right? So basically now we have got value of x square plus 1 by x square. We need value of x plus 1 by x, right? Yeah, so once again, x plus 1 by x the whole square is x square plus 1 by x square plus 2 times x into 1 by x. They cancel with each other. And this turns out to be how much? 7, right? So this turns out to be 7 plus 2, 9. So which means x plus 1 by x is going to be positive. So this is basically 3 since x is positive, right? Otherwise, there are two choices, 3 minus 3. Yeah, so we have got all values. So x plus 1 by x is 3. X square plus 1 by x square is 7 minus 1. So this is 3 into 6. That is 18. Right? Anybody has any other way of simplification? Are you Shreya?
Sir, I found x square plus 1 by x square and x plus 1 by x in the same way and then multiplied them. So then you'll get x cube plus 1 by x cube plus x square plus plus x plus 1 by x, which is 21. So then you can subtract that and get 18.
Okay, okay, yeah. And Diksha?
Yes, sir. I expanded x plus 1 by, like I cubed both sides of x plus 1 by x is equal to 3. So x plus 1 by x whole cube equals 27. And then I expanded x plus 1 by x whole cube as x cube plus 1 by x cube plus 3 into x into 1 by x
Yes.
into x plus 1 by x bracket. So 3
Yes.
x and 1 by x cancel out. X plus 1 by x is 3. So 3 into 3 is 9. X cube plus 1 by x cube plus 9 is 27. So x
Yes.
cube plus 1 by x cube is 18.
Yes. Good. Yeah, should I go ahead then? What was this number? 4. Next is now 5, number 5. And this is again KVJMO 2003. If x is 5 plus 2 root 6, obviously x is greater than 0, find 1 root x plus 1 by root x, and second x cube plus 1 by x cube. Yes, Anish. First one is correct. Okay, so first of all, if I can express x as something square, then my root x will be that something, right? So try to express a square of something. Yes, Karthik. Yes, Karthik. Good. Yeah. Yes, Anish. Correct. Anju, correct. Good. Yeah, and answer turns out to be in some simple form, not this much complicated. Upper one correct. Yes, Achyuta. Okay, so let's do the first part. Once we get first part, perhaps the second may be easier. Yeah. So x is 5 plus 2 root 6, and root 6 I can write as root 2 into root 3. So that is good. So do you see this is now 5 I can write as root 2 square plus root 3 square plus 2 times root 2 root 3, and which means x is root 2 plus root 3 square, right? So root x is, in fact, x is surely positive. So root x is root 3 plus root 2, okay? And once I get root x, by rationalizing, we'll get 1 by root x. Yes, Anju, correct. Then who has got that? Yes, Achyutan, first, second, both are correct.
Sir, I had a different method. Can I tell it, sir?
Ah, yes.
Sir, actually, instead of finding the value of root x, I actually took that. I actually directly took x plus 1 by x as 5 plus 2 root 6 plus 1 by 5 plus 2 root 6. And then I multiplied 1 by 5 plus 2 root 6 by 5 minus 2 root 6. And then I got x plus 1 by x equal to 10. And from that I solved.
Okay, okay. Ah, yes, Shreya.
Sir, I just did what we had done in the previous problem. I squared root x plus 1 by root x and got it in terms of x.
Yeah, yeah.
X plus 1 by x plus 2.
Yes. Yeah. Yeah, so squaring is good. Okay, shall I go to next page now? So root x is root 3 plus root 2. And therefore, that is 1 by root x is 1 by root 3 plus root 2 and multiply and divide by root 3 minus root 2. So that is root 3 minus root 2. So this implies root x plus 1 by root x turns out to be 2 times root 3, right? In fact, see that so far as x is real, x plus 1 by x always turns out to be greater than equal to 2, okay? Because x square plus 1 that is always greater than 2x, or x square minus 2x plus 1 that is perfect square, so that is greater than 0. So this implies this implies this, right? So in this case our answer is 2 root 3, which is surely greater than 2. Okay, who will say the second part? Many of you have got correct answer. So second part, we want to find x cube plus 1 by x cube. Those who have got 970, please tell me your way, your answer. Anyone? Yes, Anju.
So I did x plus 1 by x the whole cube is equal to x cube plus 1 by x cube plus 3 into x plus 1 by x.
Plus 3 into x plus 1 by x, yes, correct.
So x plus 1 by x the whole cube is 1000 because x plus 1 by x is 10.
X plus 1 by x, how did you get that? X is given, right?
X is 5 plus 2 root 6. 1 by x is 5 minus 2 root 6. So x plus 1 by x the whole 1 by x is 10.
Oh, good. Yeah. So this is by rationalization, right? So
Yes.
this is 5 minus 2 root 6. Okay. All of you please check if x is this, 1 by x is this. Yeah. So this is 10. So 10 cube.
So 10 cube is equal to x cube plus 1 by x plus 3 into 10.
Plus 3 times 10. Yeah, good. So this is 1000, and that means x cube plus 1 by x cube is 970. Yeah, good. So I think this is the simplest way. We go ahead.
Yes, sir.
Yeah. So far all good, all clear. Okay. Prove that cube root of 2 plus root 5 plus cube root of 2 minus root 5 is a rational. So maybe, I mean, one suggestion is call one number as x, other number as y, and try to prove that x plus y is rational. So to prove that x plus y is rational. Okay. And best way is you can take x cube, that is 2 plus root 5, y cube, that is 2 minus root 5. To see if this gives further something. Oh yes, Anish, that's right. Good. Yes, Achitan. Yeah, so basically this y is basically this is 1 by x, right?
Yes.
So y I can say is 1 by x, right? So which means x plus y is x plus 1 by x. Sorry, I think there is some sign mistake. What was that?
Sir, it will be y is equal to minus 1 by x.
Yeah. So y cube is minus 1 by x cube, right? So y is minus 1 by x. So this is x minus 1 by x, right? Yeah, Anish, how did you get that?
Yes, sir.
How did you get that x plus y equal to 1?
Sir, I did it by I first found out x cube plus y cube is equal to 4.
Hmm.
Then I used x plus y into x square minus xy plus y square is equal to 4.
Just a minute. I'll write one second. Yeah. So what was the start?
X cube plus y cube is equal to 4.
Yes.
So we factorize.
Hmm.
We can write this as x plus y into x plus y whole square minus 3xy is equal to 4.
Oh, yes. X plus y into this is x plus y whole square minus 3xy. Yes.
Now, if we take x plus y is equal to a, then we get a into a square minus 3xy is plus 3.
Minus 3xy is
Plus 3 because xy is minus 1.
what? That you get by product, right? So
Yes.
actually taking product xy is 1. Yeah. Xy is minus 1, right? Xy is
Yes.
minus 1. So this is plus, right?
Plus 3. Yeah. So from here we can clearly see a is equal to 1 is equal to is a root.
Yeah, but that will be one root, right? So the other two roots,
Then we can divide by a minus 1.
yes. Okay, so it's a cubic then. A cube plus 3a minus 4 is 0, and you see a equal to 1 is clearly a root just by inspection. You can find other roots. If I take a as 1, it is 1, 0, 3 minus 4. Yeah, so one factor is a minus 1, other factor is a square plus 8 plus 4.
Yes.
But those roots will be complex, right? And whereas a is surely real, so a must be 1. Yeah. So clearly our x and y are real, right? Which means x plus y must be real. So the only choice is a equal to 1. The other two roots are complex. So a must be 1. So which means x plus y is 1. That means x plus y is rational. Yes, Kia?
Sir, how do you get that x cube plus y cube is equal to 4?
That I think we have done on earlier page. Just a minute. X cube is 2 plus root pi and y cube is 2 minus root pi.
Oh, okay.
Yeah, all of you agree with this argument?
Yes, sir.
In fact, let me say something about that x. So here we haven't got what are values of x and y. We have directly got x plus y, right? But you try 1 plus root 5 by 2 cube. That is 1 plus y root 5 plus 3 times root 5 into 1 plus root 5 by 8, right? So that is 15 plus 1, 16 plus 8 root 5 by 8. And that is nothing but 2 plus root 5. Okay. So that is our x cube. Fine. So essentially our x is 1 plus root 5 by 2. And if x is 1 plus root 5 by 2, 1 by x, or in fact minus 1 by x, that is y. That turns out to be root 5 minus 1 by 2. You can check. I think it's 1 minus root 5, right? What is 1 plus 2 by 1 plus root 5? Minus root 5, 1 minus root 5. Pi minus 4. So this is 1 by x. Yeah, so see that minus 1 by x is 1 minus root 5 by 2. Check. 1 minus root 5 by 2. So that once again x plus y turns out to be 1. Right? In fact, what is this 1 plus root 5 by 2? That's golden ratio. So we'll talk about it when we talk about Fibonacci numbers. Yeah, anybody has any simpler way? Okay, so idea is you call one number as x, other number as y, and we have to show that x plus y is rational. And Anish is finding directly the value of x plus y, which turns out to be 1. It is surely rational. Okay. Anybody has any other way? 。 Can we go ahead then? Yeah. Let Sn is equal to sigma. Sigma stands for sum. Sigma 1 by root k plus 1 plus root k. K goes from 0 to n. And which means, so what's the meaning of this sigma notation? So I put k equal to 0. So 1 by root 1 plus root 0 plus I put next k equal to 1. And that gives me root 2 plus root 1 and so on up to lastly I put k equal to n, 1 by root n plus 1 plus root n. All of you agree? So is the notation clear? Sigma stands for summation, sum, and the index k goes from 0 to n. So I put initially k equal to 0, I it by 1, k equal to 1, k equal to 2, so on up to k equal to n. Sum of all these terms, right? Yeah, so let Sn equal to this. Find summation n goes from 1 to 99, 1 by Sn plus Sn minus 1. So which means we have to find 1 by S1 plus S naught so on up to 1 by S99 plus S98. Yeah, so firstly simplify this. Maybe you can simplify general term, the kth term by rationalization so that denominator gets cancelled and you get something in numerator. Simplify expression for Sn and then find the sum. I'll wait for you. I'll give you some time and you can put answers in chat box. Yes, Karthik. Yes, Ray. Good. This is PRMO 2013 question. written here. The answers are not correct. Maybe some calculation mistake or something. Yes, so we'll simplify general term 1 by root. What is that? K plus 1 plus root k, right? So rationalize that. Multiply and divide by root k plus 1 minus root k. So in denominator we get simply 1. Okay, so this is root k plus 1 minus root k. So which means that Sn turns out to be Sn is sigma k goes from 0 to n 1 by root k plus 1 plus root k. So that is same as sigma root k plus 1 minus root k, and k goes from 0 to n. So I put first k equal to 0, I get root 1 plus root 0. Next I put k equal to 1, I get root 2 minus root 1. Put next k equal to 2, it's root 3 minus root 2, and so on. Okay. And now you see, in fact, alternately, the terms keep cancelling. We get plus minus terms. Root 1 minus root 1, then root 2 minus root 2, then root 3 minus root 3, and so on. So such kind of sum is called as telescopic sum. You get alternative plus minus plus minus. So see that we get this is root n plus root 0, that is root n. Sorry. I can last term something wrong. Just a minute. So when I put k equal to n, this is root n plus 1, right? Minus root n, right? So my last term is root n plus 1 minus root n. Everything up to root n cancels, and what I get is root n plus 1 plus that root 0, like minus root 0. So it's root n plus 1. Sn is root n plus 1. And therefore, what we want is 1 by Sn plus Sn minus 1. That's what. So summation 1 by Sn plus Sn minus 1. So that is summation 1 by Sn is root n plus 1, right? Which means Sn minus 1 is root n, right? K goes from K goes from 1 to 99. Sorry, n goes from 1 to 99. And that is 1, n goes from 1 to 99. Again, you can rationalize this. So root n plus 1 minus root n upon, do you see denominator will be 1? Shall I write directly? So that is sigma root n plus 1 minus root n. It goes from 1 to 99. So when I put 9 first n equal to 1, it's root 2 minus root 1 plus root 3 minus root 2 plus so on up to root 100 minus root 99. And you see again we get telescopic sum. Alternately plus minus root 2 plus minus root 3 they keep cancelling up to 99. And we get root 100 minus root 1. So that is 10 minus 1. So answer is 9. Right? Yes, Kian.
Yes, sir.
Yeah, correct. I saw your answer just now.
Okay.
Yeah. Will you go ahead? Yes, Sanju, correct. Okay, so we are given number u1 is 1, first number is 1. And then onwards un plus 1 is given to be 2 times un plus 1. So for example, u2 will be, so I put n equal to 1, right? u2 will be 2 times u1 plus 1. So that is 3. Okay. So from u1 I can find u2, from u2 I can find u3 and so on. So what we have to prove is un is 2 raised to n minus 1. Yes, Shreya.
Yes, sir. Should I send it on chat or I have a solution?
So how do you do that? You can just say in one word. So,
Okay, induction.
yeah. So all of you can try by induction on n. Once you do that, I'll tell you exactly what is this problem. Okay, so induction is the easiest way to prove something. I hope all of you can get it. How do you prove by induction? So to prove it for base case is 1. Then you assume it for some n equal to say k. That's your hypothesis, induction hypothesis. And using step k, you have to prove it for k plus 1. So prove it for n equal to k plus 1. While proving this, you need to use step k. So there is this classical problem called as Tower of Brahma or Tower of Hanai. So in Indian literature, it's known as Tower of Brahma. And from Vietnam, that's Tower of Hanoi. So Lucas, in fact, who studied Fibonacci sequences, he regenerated this problem of Tower of Hanoi. And what's the problem? So I'll tell the Indian version, Tower of Brahma. So it's a story. There is a temple in Kashi, or sorry, a temple in Varanasi, where in that temple there are 3 poles. 1, 2, 3. And in one of these poles there are 64 discs with descending order from bottom up to top. So there are 64 discs, and pujaris or pandits there, priests there. What they are doing is remove one disc at a time and shift it to either this pole or this pole. So rule is never put larger disc onto smaller disc. No larger disc on smaller disc, and only one disc at a time. So in how many steps you can convert this whole structure of 64 discs from one pole into one of the other poles? So the story is, once they finish this working or shifting from one pole to some second or third pole, once they finish their job, their task, that will be the end of the world. That's the story. But in fact, the number of steps required for this is too large. And let me tell you, you can try to find out for, say, maybe 2 discs, 3 discs, 4 discs, and so on, and you can guess the answer. So suppose if I want to move 2 discs, so I'll shift this from first one from here to here. I shifted this, right? Then I can't shift this larger one onto this one, right? So I have to shift this larger onto this one. So 2 steps, and I shift this onto this one, 3 steps, right? So for 2 discs, you need number of steps to be 3. Okay. Do it for 3, do it for 4, and see how many steps you get.
Sir, for 3, it's 15.
For 3,
15, sir.
for 3 it's 7. Okay. So I have 3 discs. First I'll remove this first one, put it in second. Then this second one I'll put in this one, right? Now this largest one I can't put over any of these. So what I have to do is shift this here. So 3 steps. Now this pole is vacant. So I'll put this larger disc into this second pole. So 4 steps. And again I have to put these 2 discs onto this one. So for shifting 2 discs I need already 3 steps. So 4 plus 3. So there will be 7 steps for 3 discs. Okay.
Yes.
You can find out for 4. You can work for 4 and check how many steps you need.
Sir, I think we need 15 steps for 4.
Yeah. So basic idea is, see, if I want to shift structure of 4, first I have to shift the 3 upper disk into some other 4, and for those 3 disks I need 7 steps. Then I have to shift the last disk into the vacant pole, right? And again I have to shift other 3 disks onto this largest disk, right? So it's 7 plus 1 plus 7. So that is 15, right? And which means suppose if I have n plus 1 disk, first I have to remove n disk, for which what is number of steps I need. So suppose that number is un. Then basically for n plus 1 what I need is un plus 1 for that largest, and again plus un for that shifting of n disk onto the largest. So it's basically un plus 1 is 2un plus 1. That is that recurrence relation. Okay. So it's basically un plus 1 plus un. And you can see the numbers, they essentially turn out to be the form 2 raised to n plus 1. So 3, 7, 15, they are all 1 raised to power of 2. This is 2 square minus 1. 7 is 2 cube minus 1. 15 is 2 raised to 4 minus 1. So more generally you expect for n, answer is 2 raised to n minus 1. So un should be 2 raised to n minus 1. And that's given. We can do it by induction. Yeah, so for n equal to 1, for n equal to 1, 2 raised to n minus 1 is 2 minus 1. Okay, that is 1, and that is same as u1. So result is true for n equal to 1. Okay, assume the result for n equal to k. So we have uk equal to uk equal to 2 raised to k minus 1. That's our induction hypothesis. And we have to prove uk plus 1 is 2 raised to k plus 1 minus 1. So in some sense, answer is known in induction. We have to bring into that answer via this induction step. So for uk plus 1, I have to use step k. So uk plus 1 is 2 times uk plus 1. Right? And I hope for everyone this recurrence relation is clear. Like if I want to shift structure of k plus 1 disk, first I have to shift k disk into one of the poles, for which I need uk steps. Then I shift the largest one into the third vacant pole, which needs 1 step. And again I have to put structure of k disk onto that largest disk, for which again I need uk steps. So it's uk plus 1 plus uk, 2 uk plus 1. It's 2 times 2 raised to k minus 1 plus 1. That is 2 raised to k plus 1 minus 2 plus 1. Yeah, so this proves result for n equal to k plus 1. Therefore, by first principle of induction, result is true for all n. Belonging to n. Okay. So in fact, for the Tower of Brahma's problem, the number of steps will be 2 raised to, just a minute, where I added it. Yeah. So for this, essentially those priests will need, Pandits will need 2 raised to 64 minus 1 steps, right? To shift the structure of 64 disks. And even if you assume that they do it one step per second, with that they'll need 2 raised to 64 minus 1 seconds. And it's a huge number. So that turns out to be many years. I forgot that exact number. Some of you who is faster in calculation, you can. Yeah, Drupat, so how many years is that approximately?
Whatever it will be a lot of years.
Yeah. So we are safe, right? Okay, then we'll stop then for today with that. Yeah, so I just wanted maybe next time I'll work this binomial theorem. So you try to see expansion of 1 plus x raised to n using that a plus b raised to n and so on. And then we'll do some problems based on binomial. We'll stop there for today.